Awesome. Great to be here. I'm the only one who's not from Kerala, so I'm going to reach out to all of you later and ask for recommendations. Like we were just chatting about sambar and food recommendations. So like, okay, I've got to try out all the awesome stuff here. Talking about food, we are going to talk a lot about food today, right? So look, like my thought process was Kubernetes has been around for almost a decade and more, but it is not that friendly for newcomers to learn, right? Like typically you might have gone through the documentation and you see a lot of new things. It's hard to make sense out of it all, right? So my proposal here is I will hopefully after the end of this talk, you will be able to explain Kubernetes to anyone and including yourself if you are learning. So that's the sort of power. That's my. If you attend this talk, hopefully you will walk out with that. A bit about me quickly. I am Chinmay. I go by Chinmay185 almost everywhere on Twitter, LinkedIn, etc. And I'm a founder at a company called One2N. We work on site reliability engineering, DevOps, infrastructure. So heavily use Kubernetes, etc. a lot, right? I write stories on pragmatic software engineering, like the kind of work we do on Twitter, LinkedIn, etc. So if you're around, if you're into that kind of stuff, uh, check that out. And I like engineering, psychology, and percussion. I play tabla. And who here knows what this icon represents, what this image represents? Anyone? Yeah. This is from a game. So which game do you think this is? Sim City. Okay. I think Age of Empires. So this is a very old game. I love this game. I'm like a huge fan. So I play this game sometimes whenever I'm free. So that's a bit about me. Let's get to the meat. We are going to learn Kubernetes using this diagram. Well, not so much. We'll learn with an analogy, right? It's always easier to learn things when you're familiar with something, right? Like you are familiar with of particular way to do something, especially in the real world. It helps to learn things that way very easily. So hopefully we are going to learn Kubernetes in the next 25 minutes or so with an analogy, and we'll talk about like interesting aspects of Kubernetes with respect to the restaurant industry, right? Uh, let's start with a story. Imagine you are a restaurant manager who's just got a new job at a small mom and pop restaurant somewhere in Kerala, even, right? Like you have your job is to go in and help people out to be able to figure out seating for them. It's a very small kind of restaurant, so your job is basically find appropriate seats for incoming customers, right, and help them figure out seating arrangements in the restaurant. Well, sounds simple, right? Like it's not much of a difficult challenge. But what if the restaurant goes big and you are now going to manage this big of a restaurant, right? What could be the responsibilities for that job would be? Well, you would have to not only just ensure that people are seated in their respective seats, but you have to also make sure that you minimize the waiting time, right? For example, you don't want people to have a lot of time waiting to be seated, because otherwise then they'll just go. Then you're going to cater to new customers preferences in terms of, oh, I need a, I'm with a family, so I need a family oriented seating, or I want to drink, I'm in a mood for drink, so I need to be able to sit at a bar, for example, right? So that kind of stuff. So family, well, we have a baby, so we might want a baby chair as a sidecar, something like that. Oh, I might want a window view, right? I want a nice view of a restaurant, like looking at the river, etc. Things like that. Now, as part of your job, you'll also need to make sure that there's an efficient utilization of the resources. Essentially, the restaurant has limited space, and you have to allocate a lot of people, right? So you need to make sure that there is essentially the space is efficiently utilized. Well, let's take these things a bit even further. So imagine this massive restaurant, like it's a 3-story or 4-story restaurant with various types of arrangements, areas. Think something like Lee Meridian, this place itself. It has got massive, like you have lawns, you have outside seating, you have bar, you have a fine dining, you have fast food. There's just so many type of things, right? So let's see, at that particular place, what would your job look like? Well, you obviously will have to cater to way more customer preferences in terms of types of events, like this one conference, for example. You will have to deal with various restaurant sections, right? Okay, we have a separate conference sections, we have a separate bar section, we have a separate kid friendly, toddler friendly section, things like that. um, right, we have fast food, fine dining, we spoke about that. And you will have to manage peak load, right? You'll have to have so many people coming at a particular evening, 31st, for example, of December. So many people come in. You ought to find efficient space for all of them. And above all, I think you got to keep your customers happy. Fundamentally, that's what you're aiming for while satisfying all of these other constraints. Well, you might be like, wait, but what is this? Like, I thought I'm attending a Kubernetes talk. Like, this is, we're talking about so much about restaurant industry, right? So what has this got to do with Kubernetes? Any guesses? Say that again. Scheduler. Someone says scheduler. One more. Any more similar guesses? Yes, orchestration, right? So fundamentally, very nice. Like, this is fundamentally what Kubernetes does. It is an orchestrator. It orchestrates a lot of workloads, lot of customization. So this is no similar, no different actually from what we have in the restaurant industry and many other industries. If you've attended a opera or some sort of a musical event, right, you have these person holding sticks doing some stupid thing that you, if you don't know, if you're not from the music industry, you feel like, "Oh, what the hell is this person doing?" Right? But they're orchestrating. They're the ones who's actually keeping everyone aligned, and they're making sure the state of the cluster or the eventual workloads is at the right place. So fundamentally orchestration. Now, let's try mapping Kubernetes to restaurants or restaurant industry to Kubernetes, vice versa, right? Let's see how, is this a one-off similarity? Is there more similarities that we can learn? And imagine, like, we've been going to restaurants for a couple of, like, many times, right? You've always gone to restaurants since your childhood, etc. So you intuitively understand, at least from a customer point of view, what your experience should be and what all types of cases that you may have encountered. Now, the goal is to map those out to Kubernetes world and see if the same things do actually map out in Kubernetes. I would argue that it's a lot of similarity. So let's look at this, right? So first is, imagine the entire restaurant, this whole thing, as a giant Kubernetes cluster, right? So what have you got in restaurants? You get customers coming in. What happens in Kubernetes? So it has to run all these workloads of different types. Like, there could be databases, there could be queues, there could be stateless applications, there could be front end, back end, there could be GPUs. Like, so many types of workloads run on a cluster typically. So similarly, restaurant hosts lot of customers, right, with different taste, dietary restrictions, and whatnot. Then what does a restaurant do otherwise? It does manage and serve food. Fundamentally, that's the part of being a restaurant, right? So you kind of allocate, think of from Kubernetes perspective, a Kubernetes cluster or the scheduler and the orchestrator is going to allow is going to allow appropriate usage of resources, right? For example, you have typical nodes which are supposed to do particular type of workload, things like that. Then there is a lot of side of a restaurant that we don't get to see often, is which is the background jobs, or a lot of housekeeping goes, work goes inside restaurants, inside kitchens and whatnot. So these are some part of, you can think of them as background jobs in Kubernetes. uh, well, this last part I kind of cheat a bit. Typical restaurants don't go scale up and down as per demand. They're not. There's a limited by a physical constraint. But with Kubernetes or in cluster in our cloud environment, typically we can run autoscaler to scale up and down workloads, right? Pretty easily. So that's the great part about being in a software industry than a physical industry. So think about, what are some other analogies, right? Let's think restaurant manager, the person who's going to give you a seat as a customer when you walk in. What is their job and what are the similarities with Kubernetes? Well, they handle incoming customers, and they are the central point of contact essentially for anyone who's coming to the restaurant, right? Like, you walk in, you are greeted by someone, and then they take up your, they they understand what you want to do, where you want to sit, what you want to eat, and then they find you a place. Like if you're a party of 4, they'll give you family kind of seating. If you are like hosting a large conference, and they'll make arrangements that way, right? So in Kubernetes world, this is a kube API server, which is the central point where you interact with Kubernetes via the API server, and it's supposed to basically orchestrate your workloads, uh, right? Then there is a lot of decisioning that happens. Someone said scheduler, right? A lot of decisioning that happens in allocating the workloads. You don't want, as a restaurant industry, to have 2 people sitting in a 10 people or 10 capacity table, right? That's underutilization of resources. So then Cube Scheduler makes sure that you're able to appropriately utilize the resources. There is maintenance of, you have to also maintain current occupancy. Like there might be some places which are free right now. How do you know which table is free, which table is not free? When is the next table is going to be free? Imagine a peak load, you waiting for like 15 minutes, 20 minutes, not getting a seat. You're going to get a very frustrated experience, and you're going to go away, right? So you, in Kubernetes world, you have HCD, which actually stores all the cluster state in terms of all metadata. And this is what the API server and other components use to be able to schedule workloads, right? You also, this is kind of a broken analogy, but be with me here for a while. So you can take your customers' orders, like you have waiters in restaurants who take the orders, right? They are local to particular section of a restaurant, right? Like, as in, if you have a massive place, then you will have 2 people serving coffee right outside. There'll be some other people somewhere outside, right, for doing some other things. So this is what kube proxy and kubelet do. Like they are node related, right, and they work closer to the node than at the cluster level, for example. And we don't have a waiting area of sorts for cluster. Like wherever people come in at restaurants, typically there is a waiting area sometimes. In Kubernetes, we don't have that kind of concept, but you can think of it as pod status. Is the pod scheduled already? Is it running already? Is it completed? Is it waiting to be scheduled? Is it can't be scheduled due to lack of resources, stuff like that, right? So you see a lot of similarity there. And well, if you think about it, all this specification that, hey, I am a party of 4, I want to sit at a lake view, window view, and I have a small baby, so I need a sort of chair, right? A baby chair. If that's my specification, think of in Kubernetes world, it's kind of like our YAML spec, right? What we write, the deployment spec, essentially. So this is how you can think about the world of Kubernetes in terms of how it relates to physical orchestration work, right? I'll move a bit fast. So incoming customers are like your pods. So people are coming in, you schedule them on typical workloads. So you have a single family or a large family group. Based on that, you're going to give them different type of treatment, right? In Kubernetes world, this is like workload type. You have seating preferences, which is, okay, I need a bigger table, or I need a smaller table, or I need a table with a salad bar, sideway, having a salad bar or a coffee, whatever, right? That is your CPU memory and other kind of limits and quotas that you set as a pod. Then your food preferences. You may have, I only eat vegetarian, or I'm a Jain, or I'm allergic to some particular type of food. So I need to have that kind of customizations, right? So there's more, again, workload customizations from Kubernetes point of view. So what are these tables that we are sitting at? Like think of these as your nodes in Kubernetes cluster, right? You're coming in and you're sitting at a small, like you're a 4 people team, so you'll sit at a 4 people table. If it's more people, then you'll get attached more people, right? Stuff like that. So these are kind of your node types, if you will, right? In cloud, we have different types of nodes. So think of these as different node types. Again, there's different customizations for a particular node type. A table may be arranged differently when it's at a bar versus at a family dining seating, for example. So think of this as your node configuration and customization, right? And you might want to join a few tables. Like how many times does it happen that you go into a restaurant and a few more of your friends join in later, and you have to make seat for them as well, right? So that's a classic like auto scaling or scaling workloads, essentially. So you're gonna have to scale a particular table to be able to join new tables and get more people to be seated at that table. So now I think what I want to do is I want to go the other way. Instead of looking at, we've looked at Kubernetes right now from a restaurant point of view. I want to look at like we've looked at restaurant industry as a first class thing, and then we've tried to map it to Kubernetes. Let's actually go the other way around, and now let's look at some random sort of Kubernetes concepts that you may be struggling with to understand what is this taints and toleration. I have no idea what it means, for example, right? And let's try to see if we can map this to our restaurant industry to be able to understand it much easier and better, right? So let's start with something simple like deployment. Deployment would be something like a group of diners, like again, set of customers coming in. Imagine they don't have a lot of customization requirements as such, and they will just come and sit. They're kind of stateless system in that way. If you think about it, they'll come, they'll order a few things, they'll eat, and then just go away, right? That's the classic life cycle of a pod in that way, a deployment. Stateful set. Who here knows what a stateful set in Kubernetes is? Okay. What do you think can be equivalent of a stateful set in a restaurant industry? Like any thoughts, if you think about it? And people who are not, who don't have an idea, yeah, do you want to have a quick guess or try out? Okay. Someone says like, you said crowd, like more crowd, people coming in, something like that, right? One of the important quality of a stateful set is that it maintains the identity, right? Like you run stateful workloads like databases, queuing systems, uh, etc. On, if you are running on Kubernetes, you run it in a stateful set manner, right? Why? Because if it restarts, then it restarts in the same order, in the same, like a database primary will still remain database primary. It will get attached the same persistent storage, things like that, right? So one way to think about that in the normal, in the real world is the groups of people with these specific orders. Like I want to, like, you go with a large team of like 20 members from your company to have some dinner. There are people who have some dietary restrictions, like okay, I'm a vegetarian, or I only eat seafood, or I am allergic to a particular, ingredient in the food, so I don't want to be sitting near a particular set of people, something like that, right? That's your stateful set if you think about it. And if you move later, again, you may have experience in real life that you walk in, you sit at a restaurant, you start eating, and then you feel like, oh, actually, you know what, I should probably move to a different place. We should all sit together because a bigger table has opened up, better view has opened up, something like that. And you request the staff, hey, could we all move to that table? And when you do that, you are actually, it's kind of simulating, if you think about it, workload being terminated and recreated on a different table or a different node, right? In that case, think like as a stateful set, you will actually sit in the same set of arrangements that you were sitting typically where you were sitting, right? Like the veg, like let's say typical veg non-veg example I'm taking, those people will sit together to be able to easily share food and whatnot, for example. Yeah, you could consider it as a snapshot in that way. Um, then next is like daemon set. Daemon set, if you think about it, is something similar to, like, you have kitchen tools, or you have a standard set of procedures at a particular, like imagine again a giant big restaurant, right? What they have is, you will have seen such a massive place, so they have a set of kitchen tools, like typically your spoons, knives, etc., located every few tables away, right? So this is like a uh, s- local inventory of things that people can use, waiters can use easily. So that's kind of your daemon set. Daemon set is like something that runs in a particular section of a restaurant. In Kubernetes, you would have a daemon set running for on each node. So in this case, we are thinking, let's say we have this place, we have a coffee area right outside. We have another bigger hall. We have a right coffee area right again next to that as well, right? Something like that. So we have a local. If you think of this room as one node, then you have a daemon set running on that node in that way. A job and a cron job are pretty like sort of simple, or if I could just elaborate, you have a special one-time event, and like this conference, for example, and you have a recurring job that you will be able to, like, you have recurring parties or whatever. So that's something that you can take a look at. uh, I'm going to move a bit fast because of the time as well. But imagine again, Kubernetes, like pods we have looked at, it's just incoming customers, right? It's the simplest one to imagine. Containers, you could think of them as individual diner. Like you have a, like this table here, group of 10 people, each person orders their own dish. They share the table experience overall as a dining experience, but they have their own order, or they may be doing something separately, right? So that's, you can think of this as individual diner as customers. A pod scaling could be again like new people joining your table that we spoke about. Init containers is something interesting, right? Typically, some restaurants have, for a particular type of thing, they have more. You have this kind of thing, right? Like, hey, we've just ordered starters, we're done with the starters, and now we have ordered main course. So before the main course starts, there is some preparation that happens typically, right? Your plates are, you get new plates, new set of two forks, spoons, etc. Think of this as like one time activity which runs as part of your, like, as a init container. Essentially, when you're starting the meal, this init container runs, right? So that way. Sidecars again could be something like you have a smaller table attached. Like you go to some of the restaurants where they have a grill right on the table, right? Or there is a grill that you can just come and attach at a table, for example, uh, for uh, for starters or whatever. So that could be like a sidecar that can be attached to any of the containers or any of the workloads essentially. Namespaces again could be sections of a restaurant, like various sections. We have these rooms, like this is where the DevOps, the cloud native track is happening. There is AI, other tracks happening at different places that way, right? Then storage is interesting in Kubernetes, and you can again think of this as persistent volumes as your long form storage, right? Again, thinking from a restaurant industry point of view, imagine a massive restaurant again. So they have their own wine cellar, right? So that could be like a long term storage that they use for storing wines, right? Your ephemeral volumes could be something like your temporary prep stations or your buffet tables. This is where you're assembling a few things, and then the state is stored there. But then once the buffet is over, then that gets cleaned up essentially, right? So this is again, think of it as like ephemeral storage that you get. uh, you have this concept of storage classes in Kubernetes, various types, like you can configure, you create your own, you can attach it to your storage, and then accordingly attach appropriate storage to the pods and deployments, right, that you need. So for example, again, giving ideology or thinking in that way, you have your walk-in freezer. Not many restaurants have that, but if you had that, then imagine like a massive freezer. You have a chef kind of walks in, grabs whatever they need, and they walk out and they just use that from the freezer, right? So it's a high performance kind of storage, but it's also super costly to be able to maintain a full blown freezer, right? There could be a typically a dry storage room, which is kind of lower performance. You can put your food grains and whatever there. So that's kind of dry storage. And lastly, I think again, we talked about specialized kind of storage, which is your temperature controlled wine cellars, or you have a brewing factory next to your massive hotel restaurant, something like that, right? So these are, if you map it to Kubernetes world, that's how it kind of maps. Quickly, like configuration is kind of easy to then map accordingly. If you think about it, you have restaurants sort of policies or recipes that are pre-configured. You're using some of them already. You have config maps that are used in Kubernetes that can be typical recipe books or instructions that chefs can follow, for example. Then you have secrets, which are could be like, hey, for this, secret sambar masala or some secret recipes with some secret ingredients that heavily guarded by a particular restaurant, right? Something like that. Then there are these concepts like you have liveness probe, readiness probes. Again, if you imagine, this could be the quality checks that happen in a restaurant during meal preparation, service, things like that, right? So you're able to kind of then map and understand various Kubernetes concepts in this way. I'll just maybe give quick pod disruption, and I'll just keep them on the slide here. If you to read, pod priority could be your VIP reservations, and a special group arrives, and then uh, they're able to so like you get new people to join, and then some workloads are rescheduled, etc. Right, things like that. uh, I think I'll skip to these parts. Again, these slides will be available for you later, so you can take it. What I want to leave you with is quickly one last point, which is, although this is a based on analogy talk, like I'm encouraging you to think in analogy to be able to understand new things. I would suggest don't get limited just by analogy. Analogies break sometimes, and then that's where they're easy to get started, and but that's where you have to really apply your thinking and then learn things beyond just the analogy, right? Because at some point or the other, analogy will break, but your knowledge shouldn't be limited just to analogies, right? It's a good way to get started, but then learn to let go of those training wheels and then ride the bicycle, right? Yeah, that's it. This is how you can, like, we have a SRE bootcamp that you should try out if you're interested in SRE, reliability engineering, that kind of stuff. And check out our website, and connect with me on LinkedIn, Twitter, etc. All right, thank you. I don't think we have time for questions, but okay, yeah, we have 5 minutes for questions. So anything, yeah, please go on.
Whether to go with Kubernetes or not to go with Kubernetes.
Got it. So the question, just for repeating everyone's case, Kubernetes is complex. How do you even decide whether you need Kubernetes and not, right? So there are a few slides that I did not cover because of time, but imagine again you are a small restaurant, then you don't necessarily have many people doing different types of jobs, right? Like for example, you have a same person who's greeting you, who's giving you a seat, who's taking your order, as well as hopefully not going in the kitchen and doing stuff. But some cases you have that as well, right? It's a mom and pop small restaurant with not much scale in terms of traffic, etc. Not many types of restrictions in terms of what kind of people come in, etc. In that case, having a this kind of microservices or whatever multiple type of workload kind of setup with a Kubernetes may be overkill. So fundamentally, it is literally about the scale of the workload that you are running. If it's more than what you're able to handle, or what you're not able to handle, then Kubernetes is a good way to orchestrate things in a reliable, stable, efficient manner. But if you have a better or simpler way to orchestrate your workloads, probably go with that. Hopefully, gives you some idea. Yeah. Any other questions from anyone? Comments? Was this useful? Like any thoughts on? Because I tried this completely different thing, which is you have a physical entity like restaurant and this industry, and I've spoken with so many people to be able to who find trouble in understanding Kubernetes or explain Kubernetes in a simpler way. So which is where that was my attempt to sort of make it easier for people to understand that. All right, cool. If there is no more questions, I'll still hang around for a while. I'll be here for the whole day, so happy to chat, meet a lot of old faces and new, and have a wonderful conference. Great to be here in Kerala. Thank you so much.